Alright guys, so we're going to look at a new theorem today. This is the intermediate value theorem. Alright, so the intermediate value theorem is written there below, and we're just going to take a second to look at kind of what that means for us. Alright, so it says if f is continuous on some interval that's a to b. Okay, so that means some function is continuous from a to b. So what I'm going to do is I'm going to draw that function for you guys. So here's a, and here's b. Now I'm going to draw any random function that starts at a, ends at b, and is continuous. So it doesn't matter what that graph looks like as long as it's a function and it's continuous. Alright, so it says f is continuous in that interval. Now it says k is between f of a and f of b. Well, we know what f of a and f of b are. If I have an x value a, there's a corresponding y, which is f of a, and there's a corresponding y for my b, that is f of b. So what this says, it says that k is some number in between f of a and f of b. So I'll just pick any number in between those 2 points. It could be there, it could be down there, it could be down there. It's somewhere in between those two. Alright, so let's just pick one random one. We'll call it k. It says that there is at least one number c in that a to b range, which means there's some number c down here in between a and b where the y value of that c corresponds to k. Right, so what that really means for us is that if I have some function that's continuous, if I pick any y value between the starting and ending y value, I have to cross every single y value in between. That's what it's telling me. At some point I will cross it and there will be a corresponding x that goes with it. So for example, if I pick that k right there, there's going to be a k value over here. Now sometimes there'll be more than one value. Alright, let's say my graph, instead of looking like this, let's say my graph looked like that. Now there's two, and that's okay as well. It says there's at least one. Okay, but no matter what k value I pick, every single y value that's in between f of a and f of b has to be touched at some point on my graph, even if it's all the way at the end. So what the intermediate value theorem can do for us mathematically is to help us find a couple of different possible values. So for example, the first thing we want to do is we want to show that that function has a 0 on that interval. Okay, so the interval it gives me, those are x values. Alright, so what we're going to do is we're going to find the corresponding y values. Because we know, let's just go ahead and find those y values first. Let's find f of 1. So f of 1 means I plug in 1 for x. So I've got 1 to the 4th minus 3 times 1 squared plus 1 minus 1. And that's going to give me a value of negative 2. Then I'm going to evaluate f of 2. So that's going to give me 2 to the 4th minus 3 times 2 squared plus 2 minus 1. So that's going to be 16. 16 minus 12 is 4, plus 2 minus 1 is 5. Okay, so what this tells me is I have a graph that goes through the point. I'll go ahead and draw a picture that goes with this. Okay, I have a graph that goes through the point 1, negative 2. And I have another point at 2, 5. Well, by the intermediate value theorem, we just talked about this, there's no way to get from that point to that point. No matter how this graph moves, somehow, some way, I have to cross every y value in between it. And the y value, one of those y values is 0. So it doesn't matter where, I know in order to get to those 2 points, I have to somehow cross 0. And a 0 is, remember, when my y equals 0. So because negative 2 is less than 0 and 5 is greater than 0, what that means for me is that f of 1 is less than 0 and f of 2 is greater than 0. And because of that, that proves that I have to cross 0 in order to get from my f of 1 to f of 2. So the intermediate value theorem proves that there has to be a 0 on that interval. Now what might be a little confusing for some of you guys on this is, remember, this is a proof. We're just trying to show that this can exist. We're not actually finding an answer. So you need to show all of your work here, because all of your work is actually your answer. So for those of you who like to box things, all of that needs to be shown. Alright, so it doesn't have to just be used to find zeros. We can prove that there are any y values that exist. So for example, this next question says, use the intermediate value theorem to show to find the value of c guaranteed. So remember, this says that f of c has to equal 2. Well, in order to prove that that's true, we need to prove that there is a value that's going to be less than 2 and a value that's going to be greater than 2. Okay, we don't actually need to find what that value is. Okay, we just need to find, we don't need to find what that C value is, we just need to prove that there is one. Okay, so we know one of those numbers has to be less than 2 and one of those numbers has to be greater than 2. So to prove that, we're just going to plug in both of those values to my equation and see what I get. So the only thing that makes this question a little bit tough is that I'm working with fractions. Alright, so my first thing I need to evaluate is f of 3/2. So I'm going to do 2 times 3 over 2 squared plus 3 over 2, and that's divided by 3 times 3 over 2 minus 1. So remember, when I square fractions, I square the top number and the bottom number. So that gives me 2 times 9 over 4 plus 3 over 2, and that's divided by 9 over 2 minus 1. Now I'm going to multiply 2 times 9 over 4. Remember, that's 2 over 1 times 9 over 4, and that's going to give me 18 over 4. And then to add these together, I'm going to get common denominators. So my common denominator, this left was right when it's get multiplied by 2, so this becomes 6 over 4. And down here at the bottom, that becomes 2 over 2. So now I can finish up this math, and at the top I'm going to have 24 over 4, and that's divided by 7 over 2. So remember, when I'm dividing fractions, I need to flip the second and multiply. So I'm doing 24 over 4 divided by 7 over 2, which really means I'm multiplying by 2 over 7. So that's going to give me 48 over 28, which I can simplify. Alright, now to make a little bit of space, I'm going to make this a little bit, I'm going to go ahead and erase a lot of this so I have some more room to write. So what I just did was I evaluated f of 3 over 2, and I got the value of 12 over 7. And now we're using fractions, but remember, 12 over 7, we're trying to see, is this greater than or less than 2? So 12 over 7, it's about 1.7, which is less than 2. So if we can prove that f of 3 is greater than 2, I have to cross 2 in order to get from one point to the other. So I'm going to evaluate f of 3 now. So I'm going to plug in 3 to that equation. So I'm going to do 2 times 3 squared, which is 9, plus 3, divided by 3 times 3 minus 1. So on the top, that gives me 18 plus 3, which is 21, over 3 times 3 minus 1, which is 8. So I get 21 over 8. So if 21 over 8 is greater than 2, that gives me my proof. So 21 over 8 is like 2.6. So because the y values of both of those x values, remember those x values, that's my a-b interval from the theorem. That's the a comma b. So because I just proved that there was an f of a that was less than 2 and an f of b that was greater than 2, by the intermediate value theorem, I have to cross 2 to get from f of a to f of b. So because I proved that, or I showed that f of 3 over 2 was less than 2 and f of 3 was greater, then I have to cross pi 2 to get from one to the other. So there has to be some x value that gives me a y value of 2. Alright, so that's how we use the intermediate value theorem. Remember, we can use it to show that graphs have to cross certain y values as a result of values of some different x's.